Okay, so now we want to graph this function, and we take a look at that and we realize that it is a cubic function. We want to find all its zeros, that'll help us graph it, and then we want to use the graph to estimate where the instantaneous rate of change is positive, negative, and 0. So p of x is 2x cubed minus 5x squared minus 4x plus 3. And then by using factor theorem, I'll try p of 1, and when I calculate that I realize that it's not 0, and p of negative 1 actually does give me 0, so therefore x plus 1 is a factor of p of x. Then I'll do some synthetic division. Or perform the Ruffini method. So I'll bring this down, multiply, put negative 2 here, we'll add this to get negative 7, we'll multiply again, add down to get 3, multiply again to get negative 3, which gives me 0, which is what we need. So therefore p of x is x plus 1 times 2x squared minus 7x plus 3. And then either by decomposition or by the sum of cross products we can factor this. So therefore the zeros are x equals negative 1, a half, and 3. Okay, so what I'd like you to do is plot these zeros and then sketch a curve and check back to see if your graph matches mine. Okay, take a few seconds to do that, please. Okay, so we've got zeros at negative 1 and a half and 3. Now, the general guideline is it's roughly if we're trying to find how high these, or not really necessarily how high, but where the turning points are between the two zeros, it's roughly an average between the two zeros. So the average between negative 1 and a half would be negative 1/4. So about negative 1/4 would be where the turning point might be, and the average between a half and 3 is about 7/4. So around here. So those would be the rough estimation of where the turning points would actually occur. And so now we've got those. We can see that the curve is going to be increasing generally from left to right. That also is indicated by the positive lead coefficient of our cubic. So the graph will be something like this. Okay, that's the general shape of the graph. And so now to find where the instantaneous rate of change would be positive, negative, and 0, so the instantaneous rate of change is positive or greater than 0 everywhere where the function is increasing. So if you were to draw tangent lines anywhere along this curve where it's increasing, on those two intervals where it's increasing, that's where the instantaneous rate of change would be positive. So that occurs when x is less than negative 1/4 or when x is greater than 7/4. Okay, indicated by the average of these two zeros for this negative 1/4 here and the average of these two zeros where the turning point would be at x equals 7/4. And then the instantaneous rate of change is equal to 0. Okay, so that's going to occur at the turning points where we'll have a horizontal tangent, and the horizontal tangent indicates a slope of 0, which is the turning point where the graph changes from increasing to decreasing or from decreasing to increasing. So when we have a positive slope and then after that a negative slope, it has to go through 0. So a positive slope and the negative slope on either side of a turning point would indicate that at the turning point we have a horizontal tangent, which is a slope of 0, which is an instantaneous rate of change of 0, and that would occur at this other turning point here. Also, we've got negative instantaneous rates of change before the turning point, positive instantaneous rates of change afterwards, and then between the negative and the positive, it has to become 0 right at that turning point. So that's at x equals -1/4 and x equals 7/4. Okay, it happens at both of those. And then the instantaneous rate of change is less than 0 or negative. So that would just be between, in the last interval where we haven't looked at yet. So from -1/4, less than x, less than 7/4. Take a look at this quadratic, d of x, 3x squared minus 4x minus 1. We're going to estimate the slope of the tangent at x equals 1 using the centered interval technique. So we're going to start off with the average rate of change. And that would be f of x2 minus f of x1 all over x2 minus x1. And so we're going to use h values of plus or minus 0.001. So for the centered interval technique, we've got d of 1.001 minus d of 0.999. Okay, so because the x value is 1, and we add 0.001 to 1 to get the first x value, and we substitute in negative 0.001, or we subtract that from 1 to get 0.999. And we've got 1.001 minus 0.999 for the change in x values. So we've got 3 quantity 1.001 minus 4 quantity 1.001 minus 1 minus, and we substitute in 0.999 in for x for the second part of this, and that gets placed over 0.002, which is 1.001 minus 0.999. And after a few more steps of simplification, we then get the estimate of the instantaneous rate of change equal to 2. Okay, so please verify that yourself by simplifying all of this and working that out to make sure you do get 2 and understand why that happens. Now we want to find the y-coordinate of the point of tangency. So if we were looking for the tangent line at x equals 1, the point of tangency would be generated from x equals 1 in the function. So we've got d of 1 equals -2. So the point of tangency is 1, -2. Okay, so now what we're going to do, this is the last step. This is what we've been sort of gearing up for now. And we're trying to find the equation of the point of tangency. So, sorry, the equation of the line, or the tangent line, at the point of tangency. So now we've got the point of tangency, we've got the estimate of the instantaneous rate of change of that tangent line. So now we're going to put it all together. So when we have the slope, we know slope is y2 minus y1 over x2 minus x1. If we rearrange this, multiply both sides by the denominator, we get x2 minus x1 times m, and that will equal y2 minus y1. So if we're looking for an equation, we can make these x2's as some general point on the line, x and y, and the x1 and y1 will be our specific point. So I'm just going to now rearrange this, turn this around, so get y minus y1 equals m x minus x1. So x and y are the general points, or the coordinates of the general point, and we've got x1 and y1 here. So now we're just substituting the values. We've got y minus negative 2, which is the y coordinate of the point of tangency. The slope we found was 2, and x minus 1, where x equals 1 was the point of tangency. So y plus 2 equals 2x minus 2, therefore y equals 2x minus 4. So that is the equation of the tangent line at the point of tangency at that curve 3x squared minus 4x minus 1. Okay, so here is your work for today. Please work on the first few at home, and then the rest of them you can work on in class. Here's all the review time fun for you. Our test is in a few days, so begin preparing yourself now. And thank you for your attention, and we'll see you in class.